All right, let's get today's lesson started. Today we're going to learn the effect of additional data and outliers. Outliers was a key that could have got you a bonus in a previous lesson. Write down this and today's date and page number before beginning. Here is your warm-up. So all I want you to do is take those numbers, figure out what the greatest number is, what the smallest number is, and you don't have to find the median. How can you find the median? So the third one is telling me how you find it. Of course, you could also tell me the median if you wanted. When you're done, come on back. All right, so here are the answers you should have had. The greatest number is 178. The lowest number was 114. How do you find the median? You order the numbers and then find the middle. Now, if you found the median and you have it written down in your notebook under the warm-up, and you show it to me when you come to show me your quiz, and it's correct, I'll give you a 50. Let's move on. All right, so a scenario we have here is looking at Shawnee Davis, who in 2007 won the world singles distance in speed skating. So before, in a previous lesson, you learned that mean, median, mode can change, of course, when you add data. But if you put a data in there that's way off, it can definitely change the entire value of the set that you have. Let's take a look at what I mean. So we're going to try to find the mean, the median, and the mode of the data in this table. Okay, so if we do that, we can see the numbers we have. This is the Winter Olympic medals won. 2006 was 25, and 02 was 34. 98 was 13. It's kind of all over the place. So if you had to find the mean, you would find the mean by adding them all up and dividing by how many there are, which is 8. You'd get 15.25. The mode here, the number that happens most often, is 13. It happened twice, 98 and 94. And the median, the middle number when you reorganize them all in order, is 12.5. Well, the United States, if we add this in, also won 10 medals in 1976 and 8 medals in 1972. So if we added that table on 2 more spaces, you'd be able to put those. Now when you add the data to the table, find the mean, median, and mode. When you do this, you find out that we actually have changes in all the areas of mean, median, and mode. The mean changes to 14. Now why would the mean drop? Well, the 2 medal score tallies that we added were 10 medals and 8 medals, both of which are lower than 15.25. Now we have 2 modes. 8 happened twice, and the median went from 12.5 to 11.5. Now why did this happen? Because when you put additional data into these tables, you can change the results. Sometimes it's little significance like we have here, sometimes it's great significance. One of the things that might be added, and you got to add this as a vocabulary, is an outlier. So an outlier is the value in a set that is very different from the other values. What I want you to do is I want you to put down this table. I want you to put down the results here, and then add to the table those 2 other spots of 1976 and 1972, and then add this info so we can see how things change. And also, before moving on, add the outlier definition. I know it's a lot, but our unit is not really about adding and subtracting and a whole bunch of different things like that. It's about how do you organize your data. All right, I want you to try a little bit of this stuff on your own. So the first thing you have here is this graph. Now every time you see a whole ball, tennis ball, that's 2 wins. So as you can see, Germany has a half one, that would mean 1 win. Sweden would have a half one, that would be 1 win. Spain has a half one, that would be 1 win that you have to add to the rest. Go ahead and look at this graph that shows many times that countries have won the Davis Cup, the tennis tournament, or competition, from 1900 to 2000. I want you to find the mean, median, mode, and then B is going to add in the United States. Then you have to figure out the mean, median, mode as well. So come back when you got this all done. All right, so as you can see here in A, the mean was 4.75, the median was 5, and there was no mode. Nothing happened most often. And then when we added US, we had 31 Davis Cup championships. Your mean jumped all the way up to 10. Your median went to 7. Mode didn't change. So what did we add here? Well, we added what we called an outlier. When you add an outlier, it can change the number significantly. It's a number that's not close to any of the other ones. So if you got these right, give yourself a pat on the back. All right, so let's go through this one together, actually. If you want to try it on your own, go ahead and then come back to the video, but we're going to do this one together. So it says that this table shows the ages of the 10 youngest signers of the Declaration of Independence. So we got to find the mean, median, mode of the data. Now, you probably are looking at these and saying, does that mean there's 11 people that were 26 and 1 people that was 9? No, that's 2, okay? These are tallies. So we got to add up those tallies and make sure we know what they are. Now, before we do anything else, we probably should put these in order. 1, 1, 1, 2, 2, 3. Actually, hold on. I'm looking at that wrong. I don't want to do it that way. I want to do it for the actual ages. So this will help us actually figure out the mode, what happens most often. So if we were looking at this, the mode is the number that happens most often here, which is 33. So here I'm going to write 33 under it. Now we got to find the mean, median. So we'll write 26 twice, 29 once, 30 once, 31 once, 33 3 times, 34 twice. A lot of people signed that Declaration of Independence. So what we have to do now is we have to find the median number. So you cross off 26 and 34, 26 and 34, 29 and 33, 30 and 33, and we're left with 31 and 33. So right in between there for the median is 32. Now for the mean, we just got to add it all up. And when you add them all up and you divide by the 10 that we have there, you get 30.9. So that's the age of the 10 youngest. See how we get that? So now for letter B, what we're doing is we're adding in an outlier. Benjamin Franklin was 70. We'll add him to the end. 70 years old when he signed the Declaration of Independence. Are we going to have a change to any of the stuff here? Well, does it change the mode? Nope. Mode is still going to be 33. How about the median number? If we start going through it now, cross out the large, the bottom, next largest, largest bottom. Actually, it does change it. It moves it down to 33. So by adding that 1 on there, it changed it from 32 to 33. Well, the big change we're going to see is the median, because when we have to add 70 into it, we're going to find the median to be 34.5. So we actually changed almost 5 years when we add him. So outliers, remember this is an outlier, can change numbers significantly. So one of the things you're going to see as we work through, and we'll see here in example 2 as we use a word problem, you're going to see that sometimes you'll be asked with an outlier, you got to identify it, and then figure out the data with and without it. So it says Miss Gray is 25 years old. So she took a class with students who were 55, 52, 59, 61, 63, and 58. So she was obviously a lot younger than them. So to figure out how her information affects the data, first do the data with Miss Gray and then without. So when we add Miss Gray into it, we find that the mean is 53.3 years old. The mode, there isn't any, and the median is 58. Now if we take her out and we just look at the 50, 52, 59, 61, 63, and 58-year-olds, our mean now goes up to 58. The mode doesn't change, and the median just goes up half a point. So really, we can see here that the outlier definitely changes the average, the mean, but as far as the mode and the median goes, it doesn't change too much. So the mean is the one that's affected the most by the outlier. And the median is close to what most of the ages are already. So outliers may not change everything, but they'll change something. You can write this down if you want, but you don't have to have any of this down. All right, give yourself a shot at this. We're going to look at number 5. You're going to do this one on your own first. It says the map shows the population densities of several states along the Atlantic coast. I want you to find the mean, the median, and the mode of the data without Maine's population and then with Maine's population. So remember, the number is per square mile. So within a mile, that's how many people live in that area. Okay? With and without, come back when you got that done. Number 2, you don't have to do. You can hold off on number 2 unless you want to try that on your own. You can come to me for the answers for that one. Good luck. All right, so you probably noticed that when you don't include Maine, the numbers changed drastically than when you include Maine. 41 is a much smaller number than all those. That is a true outlier, and you can see how the numbers can change. So a lot of people that show data or try to put together information and show people what you learn, you can really skew what numbers you're trying to show to people in a lot of different ways depending on how you show your data. All right, the last thing I want you to see in this lesson today is how you can describe the data that you see and see which way works best for showing the information. Kind of what I was getting at just a second ago. So here we can see it says the Yorks are shopping for skates. They found 8 pairs of skates. The prices are there. So what's the mean, median, and mode of this data set? Well, the mean, when you add them all up and divide by 8, is 44.75. The mean is 44.75, so the mean is higher than most of the prices because the data, because of the one outlier of 75 bucks. So mean probably wouldn't be a good number to use with this data set simply because it makes the numbers go way up. Now, if we didn't include 75, you'd probably get an answer that's much more accurate, but it doesn't show that here. Now, if we look at the median, and you cross out the top, the bottom, the top, the bottom, top, bottom, top, bottom, you come down to 41. The median price here is the best description because when you're crossing out the top and bottom numbers to find the middle, you don't have to worry about an outlier. It's not going to affect it too much. So we find out that it's 41. Now, if we got rid of 75, the average would have been 40. So you're only off about $1. So in this scenario, you wouldn't want to use mean to show your information. You'd want to use median. Again, you don't have to write anything down unless you feel you need to for this one. All right, so I want you to look at these 2 scenarios, and I want you to tell me which data set would be the best. So you got to find the mean, median, mode, and then tell me which one is the best for each. Come back when you got both of these questions done. All right, so up on the board, I have the mean, median, and mode for each of the data sets. So when we were looking at the books that Katie was reading and how many pages there were, when you look at these, the one that fits best for this one is median. Really, the reason is median is a number that's very accurate because you probably aren't looking at it to the point that you see an outlier, but when you see that there's that big of a difference, there's usually an outlier, and it's 450. That book really threw off the rest of the numbers for the average, so it has to be 187. That's the closest to all the other numbers. Now, when we look at the passengers in a van and their ages, we're going to look and see that the mean was 22.7. Then the median was 18. That dropped way low, and the mode was 32. Here, our outlier of 41 really kind of affected the numbers a little bit, but it wasn't too far off. So when that's the case, when your outlier isn't that extreme, the mean is the best choice. So these are the 2 answers you should have had. If you got them right, give yourself a high five or a clap. Last note I want to put down here, sometimes you'll look at data that doesn't have numbers. It's going to have colors or things like that, like red, blue, red, stuff like that. In that case, the only way you're going to be able to describe the data set is if you're using a mode. Now I say that because it's probably going to show up on quizzes and tests. So write that down if you need to. All right, here's your box of thought. Give these two a good thinking and give good reasonable answers, and then move on to the quiz. And here's your quiz, all 4 questions. You have the data there for number 1, find the mean, number 2, find the median, number 3, find the mode. We're going to throw an outlier in at you. And how does that change the mean? Good luck. See you later.